Hello everyone, welcome back to our channel Discover Knowledge with Anu. Today we shall see another method of solving given matrix in normal form to find out the rank of a given matrix. So normal form nothing but every m cross n matrix of rank R can be reduced to the form IR or IR of the matrix and 2 by 2 matrix IR 0 0 0 by a finite chain of elementary row and column operations where IR is the row unit matrix the above form is called as normal form. So every m cross n matrix, either it is a square matrix or either it is like 2 by 3 matrix, 3 by 4 matrix, 3 by 3 matrix or 4 by 5 matrix. It might be any matrix. So we have the rank of the matrix and that can be reduced to the form of these three forms by a finite chain of elementary row and column operations, means by using elementary transformations and by using echelon form, by changing the column operations where IR is the row unit matrix. The above form is called normal form. We shall do one problem based on normal form. Reduce the matrix to normal form and find its rank. If the matrix A is equals to 2, 3, 7, 3 minus 2, 4, 1 minus 3 minus 1, which is of 3 by 3 matrix. Now, we have to use the same method of echelon form in the starting as we did in the last previous problems. Now given A is equals to 2, 3, 7, 3 minus 2, 4, 1 minus 3 minus 1. Now applying the row operations from R3 to R1 and R3 to R2. Now R2 implies to make these elements as 0. To make these three elements as 0, first I am using operations for row to make these two elements 0. From R2 to R1, so R2 minus 2R1 minus 3R1. Then this row becomes 2 into 3 minus 3 into 2. 6 minus 6, that is equals to 0. And next 2 into minus 2 minus 3 into 3, that is equals to minus 13. And 2 into 4 minus 3 into 7, that is equals to minus 13. Next Now applying the same operation for R3 to R1. R3 implies 2R3 minus R1. So when we multiply this element with 2 and minus of 2, it becomes 0. We get it as 2 into 1 minus 2 is equals to 0. 2 into minus 3 is equals to minus 9. And 2 into minus 1 minus 7 is equals to minus 9. Okay, we got these elements. Now form a matrix 2, 3, 7, because first row anyhow it does not change. Second, 0 minus 13 minus 13. Next, 0 minus 9 minus 9. This is a matrix which we got. And now to make our problem very easy and calculation very easy, now I am dividing this R2 and R3. I am dividing R2 by minus 13. So, and next R3 by minus 9. So, when we divide these elements by minus 9, it becomes 1, 1. And when we divide the R2 by minus 13, it becomes 1, 1. And our calculation becomes more easy. We get the matrix as 2, 3, 7, 0, 1, 1, 0, 1, 1. Now, this element we have to make it as 0. I am applying the row operation from R3 to R2. R3 implies R3 minus R2. Then matrix becomes 2, 3, 7, 0, 1, 1, 0, 0, 0. This is of the echelon form. Now, this is a column 1, column 2, column 3. Now, till here we completed the echelon form. To find out the normal form, the problem proceeds like whatever the row operations we have applied for in the starting. Similar way, we have to find out for the columns. Now, applying the column operations C1, C3 to C1 and C3 to C2 in the first step, it becomes C2 implies 2C2 minus 3C1, because now after getting these, we have to make these elements as 0. To make these elements as 0, we are using column operations. Now C2 implies 2C2 minus 3C1. This column becomes, C2 becomes 2 into 3 minus 3 into 2. We get it as 0. And 2 into 1 minus 3 into 0. We get it as 2. Similarly, applying the row operations from C3 to C1, we get it as C3 is equals to 2C3 minus 7C1. From C3 to C1. Then 2 into 7 minus 7 into 2. That is equals to 0. And 2 into 1 minus 7 into 0. That is equals to 2. Now writing this into the matrix, this column does not change. C2 changes as 0, 2, 0. and third column we got it as 2 0 0 2 0. Now making this element as 0 because all other these two elements became 0 and we have to make this element as 0. Then I am applying the operations from C3 to C2. Then C3 implies C3 minus C2, that is equal to 2 minus 2 is equals to 0. We get the matrix as 2 0 0 0 2 0 0 0 0. Now this is of the echelon form and this is of the normal form. Now furthermore, to find out the rank of a matrix, dividing this column by 2 and dividing the second column by 2, we get the matrix as 1 0 0 0 1 0 0 0 0. Now this is of, we are writing in the form as I2 because it is identity matrix of order 2 0 0 0. So as we discussed in the previous one, at the starting of the class, it is of the form I2 0 0 0. Now it is in the form of this and therefore the rank of a matrix A is 2 since it is of 2 by 2 matrix. Now therefore the rank of a given matrix is 2. We will see one more problem on normal form. Reduce the matrix to normal form and find its rank if A is equals to 1, 3, 4, 5, 1, 2, 6, 7, 1, 5, 0, 10. Now given matrix A is equals to 1, 3, 4, 5, 1, 2, 6, 7, 1, 5, 0, 10. Now applying the row operations from R2 to R1 and R3 to R1. R2 implies R2 minus R1. We get it as 1 minus 1 equal to 0, 2 minus 3 equal to minus 1, 6 minus 4 is equals to 2, 7 minus 5 is equals to 2. Similarly, applying the row operations from R3 to R2, R3 minus R1, we get it as 1 minus 1 0, 5 minus 3 is equals to 2, 0 minus 4 is equals to minus 4 and 10 minus 5 is equals to 5. Now this is our diagonal. We have to make these all elements as 0. Now writing the matrix, we get it as 0 minus 1 2 2 and 0 2 minus 4 5. Now next, applying the row operations from R3 to R2 to make this element as 0. R3 implies R3 plus 2R2. Then 2 plus 2 into minus 1, that is equal to 0, and minus 4 plus 2 into 2 is equals to 0, 5 plus 2 into 2 is equals to 9. We get the matrix as 1 3 4 5, 0 minus 1 2 2 and 0 0 0 9. We got this matrix. Till here echelon form is completed. Now proceeding for further to make this element as 0. Then applying the column operations from C3 to C1 and C2 to C1, C4 to C1. Oh, we get it. Now applying the operations C2 to C2 implies C2 minus 3C1 from this to this column. We get 3 minus 3 into 1, that is equal to 0, and minus 1 minus 3 into 0, that is equal to minus 1, and 0 minus 3 into 0, that is equals to 0. Now C3 implies C3 minus 4C1. Now C3 implies C3 minus 4C1. We get it as 4 minus 4 into 1, that is equal to 0. 2 minus 4 into 0, that is equal to 2. And 0 minus 4 into 0 equals to 0. Next, applying the column operation from C4 to C1, we get C4 implies C4 minus 5C1. 5 minus 5 into 1 is equals to 0. 2 minus 5 into 0 is equals to 2. And 9 minus 5 into 0 is equals to 9. Now writing this C3, C2, C3 and C4 in the matrix, we get it as we get the matrix as 1 0 0 0 0 0. Okay, according to the column wise this does not change, and from here 0 1 0 0 2 0 and 0 2 9. This is the matrix which we got. Now applying the operations from C4 to C3 to make this element 0. Now there are 3 elements are left over. We have to make them 0. Now I am applying the operations from C3 to C4 to C3. Operation as C4 implies C4 minus C3. Then 2 minus 2 equal to 0. 9 minus 0 is equals to 0. 9. And next applying the operation from C3 to C2 as C3 implies C3 plus 2 into C2 to make this element 0. Then what we get? C3, that is 2 plus 2 into minus 1, that is equals to 0. And this anyhow 0 plus of 2 into 0 is anyhow 0. Okay, writing the matrix 1 0 0 0 minus 1 0 and 0 0 0 0 9. We got it as this. Now interchanging from C4 to C3. Okay, before this I am dividing the C4 by 9. Dividing the column 4 by 9, it gives us this matrix. Now I am interchanging from C4 to C3. Before that also we can do, but it will be more easy for us. Now interchanging, it gives us 1 0 0 0 0 minus 1 0 0 0 0 1 0, because I interchange this column to C3. Now dividing the column to C2 by minus 1, we get it as 1 0 0 0 1 0 0 0 1 and 0 0 0. This is of, if you see this one, this is of I3. I3 nothing but it is an identity matrix which is of order 3. Now it is in the form of IR and 0. We got here as I3 0. Now here R nothing but rank of a matrix. So here R is equals to 3. Therefore rank of the given matrix is 3. Here are few problems based on same topic. Try these problems. If you get any doubts, drop it in comment section. Thank you.